Hello students, today we'll study on vector. Vector is the concept introduced to represent both magnitude and direction of a physical quantity. All the physical quantities we come across can be categorized into two groups. One is scalar quantities and another are vector quantities. Quantities having only magnitude are termed as scalar quantities, whereas physical quantities having both magnitude and direction are termed as vector quantities. Then we'll study how to represent a vector quantity, then categories of vector quantities, types of vector quantities, and operation on vector quantities or vectors. A vector quantity is represented by a straight line with an arrow head over it. That means the arrow end is head and start end is the tail. While writing, we write if O is the start point and other end is A, we write the vector as OA with a arrow over it, where OA represents its length or magnitude and direction says from O towards A. Categories of vectors can be of two types. First is polar vectors and other one is axial vectors. The vectors which have starting point are termed as polar vectors, whereas vectors which represent rotational effects and act along the axis of rotation is termed as axial vector. Under types of vector, we will come across equal vectors, negative of a vector, modulus of a vector, unit vector, fixed vector, free vector, collinear vectors, coplanar vectors, co-initial vectors, co-terminus vectors, zero or null vector. If two vectors have same magnitude and same direction, then these two vectors are termed as equal vectors, whereas negative of a vector is represented by having same magnitude but having an opposite direction. Modulus of a vector is magnitude or the length. This magnitude of vector is the scalar quantity which has no direction, only magnitude. Unit vector is a vector have its direction but magnitude is 1 or units. Unit vector can be calculated by the vector itself divided by the modulus of the vector, and it is represented by a cap over the letter. Fixed vector is where initial point of the vector is fixed is termed as fixed vector. If the initial point is not fixed, this type of vectors are termed as free vectors. Velocity vector of a particle moving along a straight line is a free vector, whereas position vector of a particle is a fixed vector. Position and displacement vectors are defined as position vector is that vector which gives position of an object with reference to the origin. It tells the straight line distance of the object from the origin and direction of the object with respect to the origin or the angle it makes with the reference axis. Displacement vector tells how much an object has changed and in which the object has changed its position. That is, displacement vector tells how much an object has changed its position and in which direction it has changed its position. Now, other types of vectors are collinear vectors. The vectors which act along the same line or along parallel lines are termed as collinear vectors. That is, angle between them is 0 degree. Then this, if the angle between them are 0 degree, are termed as like or parallel vectors. If the angle between them is 180 degree, are termed as unlike or anti-parallel vectors. Coplanar vector is if the vectors act in the same plane. Co-initial vectors are if the vectors have same initial point. Co-terminus vectors are if all the vectors have common terminal point. These vectors are termed as co-terminus vectors. Now, let us study what is zero vector and its properties. Zero vector is a vector which has zero magnitude but have some direction. Properties of zero vectors are such. Zero vector added to any vector A gives the result A vector. If a zero vector is multiplied by 0, then gives again a zero vector. If any vector A multiplied by zero gives zero vector. Now, under operation of vectors, we will study addition of vectors and product of vectors. For addition of vectors, we will have three laws. One type of addition is triangle law of vector addition. Another is parallelogram law of vector addition, and third is polygon law of vector addition. Whereas product of vectors will have dot product or scalar product of vectors, and another is cross product or vector product of two vectors. Under triangle of vector addition, when two vectors are added, the resultant of these two vectors is represented by one side of a triangle in which these vectors are sides of the triangle. That means if two given vectors represent sides of a triangle, then the third side in the opposite order represents the resultant of vector addition of these two vectors. That is, if two vectors represented both in magnitude and direction by the two sides of a triangle taken in the same order, the resultant of these two vectors will be represented both in magnitude and direction by the third side of the triangle taken in the opposite order. Next is parallelogram law of vector addition says if two vectors can be represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a common point, then their resultant is represented by the diagonal of the parallelogram passing through that common point. Polygon law of vector addition says if a number of vectors are represented both in magnitude and direction by the sides of an open polygon taken in the same order, then their resultant is represented both in magnitude and direction by the closing side of the polygon taken in opposite direction. Vector addition is commutative, that is if A plus B is added, A plus B equal to B plus A. Vector addition is associative, that means if three vectors are there, first A and B are added and the resultant if added with C will be same as A is added with resultant of B and C. Now to find out analytical method of vector addition, that means if two vectors are A and B and they make an angle theta, that means if two vectors to be added and the angle between them is theta, the resultant vector value is square root of vector A square plus B square plus 2AB cos theta. That means the resultant vector magnitude R square will be equal to A square plus B square plus 2AB cos theta, or R will be under root of A square plus B square plus 2AB cos theta. And this resultant will make an angle beta with the first vector, then tan beta will be B of sin theta, where B makes theta angle with vector A, then tan beta equal to B into sin theta by A plus B cos theta. Now let us study how to represent and find out unit vectors or base vectors. In a right-handed Cartesian coordinate system where we have three axes, x-axis, y-axis and z-axis, these axes are represented by these three unit vectors I cap, j cap and k cap. As three axes are perpendicular to each other, these three unit vectors I cap, j cap and k cap are also perpendicular to each other, whereas magnitude of I is equal to 1, magnitude of j equal to 1 and magnitude of k also equal to 1. Now let us study how a vector can be represented with help of its rectangular components. When a vector is resolved or represented using its components along mutual perpendicular directions, these components are termed as rectangular components of the given vector. If any vector is expressed using its x component or components of this vector along x-axis and components of this vector along y-axis, where ax is the horizontal or x component of A and ay is the vertical or y component of A, then A can be represented as ax I cap plus ay j cap, where its magnitude or A mod equal to square root of ax square plus ay square. Resolution of a Poisson vector into its rectangular components can be of if R is the Poisson vector of any object or position. This can be represented as its x coordinate times I cap plus y coordinate times j cap, or if R is the Poisson vector which is represented from origin O up to point P, coordinate of point P is x and y, then R can be represented as R with a overhead arrow equal to x times I cap plus y times j cap, and magnitude of R will be R square is equal to x square plus y square, or R is equal to square root of x square plus y square taken as whole. Here x is the r cos theta, where theta is the angle this Poisson vector r or OP makes with x axis. Then x component represents r times cos theta, where r is the magnitude of the Poisson vector, and y coordinate or y value equal to r times sin theta. Now, if ax, ay and az are the rectangular components of a vector and I cap, j cap and k cap are the unit vectors along x, y and z axis respectively, then vector A represented by A with arrow overhead equal to ax times I cap plus ay times j cap plus az times k cap, and magnitude of A is magnitude of A square equal to ax square plus ay square plus az square, and unit vector along A is vector A divided by magnitude of A. Which is equal to vector A represented as Ax I cap plus Ay j cap plus Az k cap divided by magnitude of A, which is square root of Ax square plus Ay square plus Az square taken as a whole. Now let us study vector product of two vectors. The product of two vectors can be of scalar product or dot product and cross product or vector product. A scalar product of two vectors gives rise to one scalar value. That means if we have two vectors, vector A and vector B, and their scalar product is represented by vector A dot vector B, the result becomes magnitude of A multiplied by magnitude of B multiplied by cos of angle theta between them. This becomes AB cos theta. This shows both A vector and B vector have directions, whereas their dot product or scalar product has no direction, only magnitude. That becomes A B cos theta. Properties of scalar product are as scalar product is commutative, that means A dot B equal to B dot A. Scalar product is distributive over addition, that is A dot whole B plus C equal to A dot B plus A dot C. If A and B are two vectors perpendicular to each other, then their scalar product is 0, because theta becomes 90 degree and cos theta becomes 0. Then A plus B comes, AB cos theta is equal to AB cos 90 is equal to 0. If A and B are two parallel vectors, then theta becomes 0, cos 0 becomes 1. In that case, A dot B becomes AB, or multiplication of magnitude of A and magnitude of B, that is the maximum value. If A and B are two parallel lines or vectors having opposite directions, then their scalar product has maximum negative magnitude, that is theta becomes 180 degree, cos theta becomes minus 1, and A dot B becomes minus AB. Scalar product of a vector with itself, that means theta becomes 0, then A dot A becomes A dot A cos 0 degree is 1, then A cross A is equal to A magnitude square. To find out the scalar product or dot product of unit vectors, we say I dot I equal to 1, j dot j is equal to 1 and k dot k is equal to 1, whereas I dot j, the angle between them becomes 90 degree, cos 90 is equal to 0. In that case, I dot j equal to 0, j dot k is equal to 0, and k dot I also becomes 0. Another way of representing mathematical representation of A dot B is equal to A dot B equal to A x, that is x component of A, and bx, x component of B, plus ay multiplied by by plus az multiplied by bz. That means A dot B, vector A dot vector B equal to x multiplied by bx plus ay multiplied by by plus az multiplied by bz. Now, cos theta, or the angle between them is theta, is cos theta becomes A dot B divided by magnitude of A and magnitude of B. Now to find out vector product or cross product of two vectors, we find vector A cross vector B equal to magnitude of A and magnitude of B then vector A cross vector B equal to magnitude of A multiplied by magnitude of B multiplied by sine of angle theta. That's the theta is the angle between A and B, and a unit vector perpendicular to both A and B. Then it becomes, if n is the unit vector perpendicular to both A and B, A cross B becomes A into B times sine theta into n cap, where n cap is the unit vector that is perpendicular to both A and B. Now, this direction of A cross B can be found out using right-handed screw rule or right-hand thumb rule. In right-hand screw rule, if screws is if the screw is moved from A to B through some angle theta, then A cross B will have its direction in which screw advances. Now, under right hand thumb rule, if two vectors A and B represents means If curl the fingers of the right hand in such a way that they point in the direction of rotation from vector A to B through some angle theta, then the stretched thumb points the direction of vector A cross vector B. Now to study properties of vector product. Vector product is anti-commutative, that is A cross B equal to minus of B cross A. Vector product is distributive over addition. A cross B plus C is equal to A cross B plus A cross C. Vector product of two parallel or antiparallel vectors is a null vector because angle between them is 0, where A cross B equal to magnitude of A multiplied by magnitude of B multiplied by sine of angle theta between them. If angle is 0, sine 0 becomes 0, then A cross B becomes a 0 vector. Same way, if theta is 180 degree, then also sine 180 becomes 0 and A cross B becomes 0 vector or null vector. Vector product of a vector with itself is a null vector because theta becomes 0 cross A becomes A multiplied by A times sine 0 degree, or magnitude of A into magnitude of A times sine 0 degree and n cap. Then magnitude becomes 0 and it will have only direction, that is perpendicular to A. If angle between vector A and vector B is 90 degree, then sine 90 becomes 1 and A cross B becomes AB sine 90, that is A magnitude times B magnitude. Now, then its direction will be perpendicular to both A and B, or direction will be perpendicular to the plane where A and B lies. Now, to find out vector product of unit vectors, we say it is the sine theta, or theta is the angle between these vectors. If theta is equal to 0 degree, sine theta becomes 0. If theta is 90 degree, sine 90 becomes 1. That's why I cross I, theta becomes 0, then in that case I cross I is 0 vector, j cross j equal to 0 vector, and k cross k also becomes 0 vector. Whereas I cross j becomes k and j cross k becomes I and k cross I equal to j. If these unit vectors are multiplied in opposite order, as a special case, j cross I becomes minus k and k cross j becomes minus I and I cross k becomes minus j. Another method of to determine the scalar product vector product of two vectors a and b as a vector cross or multiplied by b vector equal to the determinants of their components. That is, the vector product of two vectors can be expressed in terms of their rectangular components as a determinant. And if the theta is the angle between two vectors, then we can find out sin theta equal to magnitude of a vector cross b vector divided by a vector magnitude multiplied with b vector magnitude. That is sin theta equal to magnitude of a cross b by magnitude of a and magnitude of b. The unit vector n that becomes perpendicular to the plane in which vector a and b lies can be found as a vector cross b vector divided by a cross b magnitude. That is, as the unit vector earlier explains, vector itself by magnitude of the vector is the unit vector along that direction. In our next class, we will study laws of motion.